Welcome to Study for GATE and ESE Solution. We are continuing with our series for 2020 GATE and ESE Solution from the previous year paper from 1995 to 2019. So this is question number 28. So let's start today. So this is a figure they have given, and in this figure they are asking find out the value of E and the value of I. So this is the voltage source and I is the current. So let's start from the right side. This is the 4 ohm and 1 ohm connected parallel, and through this 4 ohm connected 2 ampere. So this two, there is no across no resistance, so this two have same voltage. So here are 4 into 2 8 voltage, means here also 8 voltage. So current flowing through will be the 8 ampere. So let's start its solution. So this is the figure they have given. So in the question they have given that this is a 4 ohm current will be flowing through 2 ampere. So voltage drop across will be 2 into 4 is equal to 8 volt. So this 4 ohm and 1 ohm they are connected parallel. So voltage across this one will be equal to voltage across this one, because in parallel condition the voltage will be same. So the voltage drop across will be 8 volt. So voltage will be 8 volt, 1 ohm resistance, the current drop will be 8 by 1 is equal to 8 ampere. So the total current flowing through this 1 ohm resistance will be 8 ampere. So apply here KCL. So this two also going, so 8 also going. So this one is coming here through the 1 ampere. So 2 plus 8 will be 10. So through the 1 ampere resistance the current is coming here 10 ampere. So the voltage drop across will be 1 into 10 will be 10 volt. So voltage drop across will be 10 volt. Let's start again the KVL equation. So the symbol will be plus minus here also current will flow in this direction, so plus or minus. So apply KVL equation here. This we know, we don't know, that's why minus 6, because this is a plus sign, this is minus sign. So minus 6 plus, if you sign change this is not a matter. So minus 6 plus the plus 2 plus 10 volt minus plus 8 volt. So V6 is equal to 18 volt, because the voltage drop across will be sum of these two voltage drop. So this voltage drop will be the 18 voltage drop. Either you can take sign change, once either we can take the sign change, because we are changing all the voltage drop across connected. So V6 will be the 18 voltage. So this will be the 18 across the voltage drop will be the 18 voltage. So 18 voltage drop and 6 ohm resistance. So the current flow will be 18 by 3. So the current flow will be 18 by 3 will be the 3 ampere current is flowing through. So apply here. This is the KCL apply here. So in this way 10 ampere is current is going. In this R6, so 6 in 6 ohm current is going 3 ampere. So this 10 plus 3 will be the 13. So the I value will be total 10 plus 3 is equal to 13 ampere. So I is equal to 3 plus 10, which is the 13 ampere. So across this one with 13 ampere I is current is flowing. Let's this is a voltage source, we don't know, we have to find out this one. So consider here 1 ohm resistance current is flowing 13 ampere. So this is 1 ohm, so 13 into 1 plus or minus, so 13 volt, and apply across this one. So 3 ampere is flowing, 6 ohm is there, so 18. So already we have calculated this 18 volt. So apply here KVL. So E, so we have taken outside E is equal to this E, we are taking separately. E is equal to 13 into 1 plus 18, because already we have calculated this one 18 voltage. So E is equal to 13 plus 18 is equal to 31. So E will be the 31 volt. So we have calculated E is 31 volt and I is 30 ampere. So in this problem the the V is 31 volt and I is the 13 ampere. Let's see in question number 29. In this figure they have given this figure A represent time versus current and figure 2 represent voltage versus time. So look at this figure 1 and figure 2. In figure 1 y axis represent current, x axis represent time. So here this is the linear increasing current with respect to time. So there is a each and every second change of current is take place because this is a linear representation. And see the figure number 2. Here the voltage is constant with respect to time because from 0 to 2 second, let's consider the voltage is remaining only constant here. So from this figure we can be understand that current is changing, voltage is remaining constant. So it is the property of inductor. So inductor, because the normal property of inductor will be change in current only. It will be work when current is constant, it will become 0. When current is constant, it will become 0. But in voltage should be constant. Take is reverse of capacitor. Capacitor will be change only in whenever change in voltage. But when it current will be in constant in capacitor. So this is a three observer we can use: resistance, capacitor, or inductor. So this is the normal property of a inductor. When it will be opposes a sudden change in current, means it will be work only on current, but capacitor will be work only on change in voltage. So in this figure only current is changing, so voltage remaining constant. So from this figure we can understand that it's a inductor circuit. So we can calculate slope for this one. So for current slope we can calculate here. So this is the point 0, 0. This is the coordinate point 2, 2. So slope will be y1 minus y2 minus y1 by x2 minus x1. So 2 minus 0 by 2 minus 1, which is 1. So current of this straight line will be the linear equation. So the current equation is I of t is equal to t. We normally know that the relation between voltage and current is in inductor is VL is equal to L d I of t by dt. So but here VL is 2 given is, this is constant. So 2 is equal to L d I of t by dt, but d I of t by dt it is given only t. So dt by dt is equal to 1 into 1. So 2 is equal to L we have got. So L is equal to 2 Henry. So the in figure we have to call the L value is equal to 2 Henry, because in this two figure they are telling to calculate they are telling what is the element, because current only change means it's an inductor. So it's an inductor and its value will be 2 because we have calculated from the formula. Let's see the next question. In question number 30 they are telling that they have given a triangular voltage of peak value 1 volt and its frequency will be 1 volt. This is the input voltage and it is connected parallel with a resistance and a parallel capacitor. Means a voltage resistance, a voltage source, a resistance and a parallel, 3 are connected in parallel. They are asking find out the current waveform that is flowing through the voltage source. So they have given 4 figure. This A will be the triangular, not triangular, it will be square wave. B will be the this C, D. So we will calculate V cell we are getting. So this is the figure they have given, because V of t, this is the voltage source connected in parallel with one resistance R, and this is also connected in for one capacitor. So this is the figure they have given. So we can calculate I is equal to the current flowing across IR plus the current due to capacitor. So the total, this they are asking what is the waveform of this current. So normally we can calculate. So this V of t is given. So voltage across also V of t. So voltage across V of t, because they three are connected parallel and across no resistor is there. So the all three are the equal voltage. So IC we can calculate C d V of t by dt. So IC is equal to d V of t by dt, because C is given is 1, but IR, so I is equal to IR plus d V of t by dt. And see, this d of t they have given. This is the figure, this dV of t they have given, because they have told in question that this is a triangular, this is a triangular waveform. So the peak value will be 1 volt. This is a triangular waveform. Its time, and they have given frequency will be 0.5. So time period will be 1 by frequency. 1 by frequency. So its value will be 1 by 5 is equal to 2 second. So frequency is given 0.5. So its time period will be 1 by f is equal 1 by 0.5 is equal to 2 second. So its time period will be -1 to 1. So it will -1 is equal to 2. So time period will be 2 here. And in this case we have got that this is the total current addition of IR plus C dV by dt. But this is the waveform for this one, V of t by dt. When we derivate this total value V of t is given this one. When we derivative V of t from this triangular equation to, we are getting this one, because when we will derivate a triangular wave, we will get a square wave form. This is a normal formula. This is when we study for signal system. I will tell how from this one triangular to this square wave we are getting. I will tell that when I will teach there in get paper solution. So just remember for this purpose, so derivative of triangular wave will be square wave. When we derivate triangular wave, it will become square wave. So V of t is this one. When we derivative this V of t, we are getting square wave. So we are getting here I of t, this is a total current is equal IR plus dVt of dt. So this one we are getting, this one represent this figure, but this one, but consider, but when we see IR, when only resistance is there, its time will be 0. So in time frequency there is no changes, plus only there is amplitude only changes. This say when resistance is there, we should be focused 3 part. One is no time period change. 2, only magnitude change. Third part will be the here only magnitude, and only positive part will be change. Positive part will be addition take place. So we figure this one. This one will be some quantity. So add this one here. So we are getting here only some increasing here point value, because here 1 to listen +1 to -1 to this time period will always remain constant. So some addition, this some quantity we are adding, that's why its value only changes, because this one is a constant, it will be change only magnitude. So here is some adding some values over here. So the final figure will be, we are getting in this way, because time period will be always remaining constant here. Time period it's won't change. -1 to +1. Its negative part also won't change. Only the positive part is slightly changing from 1 to 2. So this is the figure for the question number 30. So we can assume from here this won't be there, this also won't be there, this also won't be there, because listen here is the negative part is increasing, but we have seen that only positive part is increasing there. So the option number D is the correct answer. Come for the next. So this is a question number 31. So in this question, one voltage source is there. In this question, one current source is there, and its resistance will be R, and its it will be power the consume 8 watt. This is the question they have given. I am explaining the meaning of the question. And when we consider another voltage source whose value will be equal to current source and the same resistance, but it will be consume the power 4.5 watt. So they are asking find out the current source and the value of the R. So I'm explaining again. One current source is there, the resistance will be R, so its power consumption will be 8 watt. Consider another voltage source whose value will be equal from the current source and the same resistance, but its power consumption will be 4.5. Means voltage source power consumption will be 4.5 watt, current source power consumption will be 18 watt. So they are asking find out the value of the current and voltage. So let's consider I is the current and resistance will be R. So the power consumption will be I square R, which is a 18 watt. But in question given that I is equal to V and the same R also the same. I is equal to V and the R also same. So power consumption due to V is equal to P2 is equal to V square by R. But V is equal to I is given. So V is equal to I is given. So in terms of V, I can put I here because V is equal to I. So V square by R is equal to, in terms of V, I can put I. So I square by R. So I square by R is equal to 4.5 watt. 4.5 watt. Cross multiply this one. So I square is equal to 4.5 R. This is the equation 2 and this is equation 1. Put the equation 2, this is the equation 2. Put the equation 2 in equation 1. We are getting that I square R, we are getting the I square R. This is the equation 1. I square R is equal to 18, but I square value is equal to 4.5 R. So put here I square, in terms of I square we are getting 4.5 R into R. This is the previous R. So is equal to 18. So I square is equal to 18 by 4.5. So R value we are getting root over 18 by 4.5 is equal to root 4. So is equal to 2. So R is equal to 2 ohm. So the resistance we are getting is equal to 2 ohm.